What's up, everyone? I spent Thursday at the tutoring center and I had a lot of similar questions. And just in case you guys needed some help, I decided to preemptively make a video of some of the review questions here for the test on Monday to help you guys out. So let's take a look at first, let's understand the differences um, between faces, vertices, and edges. So, one reminder is, and something that might even help you guys on the test, is to always highlight your base and understand when we're looking for perimeter versus area, right? So, whenever we're looking for the area of a base, that's because we're trying to find the volume, right? So, if you're looking for the area of the base, you're going to find volume. If you're looking for the perimeter of the base, you're looking for surface area. Another thing, right, is that if you always highlight the base, you won't get confused and accidentally start multiplying numbers that don't have anything to do with your base or adding numbers to it that aren't going to be part of your base here. So, if we take a look just like at number one here, this is one thing to remember about pyramids is the pyramids all change names dependent on the base that is provided or that they are based on. So in this case, I have a one, two, three, four, five, six. I have a six-sided polygon, which is a hexagon. So this is a hexagonal pyramid, pyramid, I imagine pyramid. All right, this is a hexagonal pyramid. And um, now remember that faces are essentially just all the sides of this pyramid. So it's kind of easy to tell how many faces we have, right? Because we have a face attached to every side. So since we have of the base, right? So since we have one face here, two face here, right, and then so on and so forth for six sides. I'm sorry if that was a little messy, but um, that means that we're going to have six faces plus the base, which gives us a total of seven faces. The vertices are just, think of vertices as corners. So here I have a corner here, one corner, one corner, one corner. How many corners is that? So we have six corners at the bottom plus the one. So this is seven. And when I say corners, remember that vertices are where two lines intersect. So it's essentially where the edges intersect. And think of, and then again, an edge is like the edge of a desk, the edge of my laptop, the edge of my iPad, right? Um, so my edges would be these one, two, three, four, five, six, and then that's just for the lateral area. But then I have six more edges on my base. So I have a total of 12 edges. Cool. All right, wonderful. So I'll let you guys figure these out, but I already have the answers, so I'll just write them in just so you guys can see them, right? This is a triangular prism. This has a total of five faces, six vertices, and nine edges. Then this is the trapezoid face, so trapezoidal prism. It has a total of six faces, eight vertices, and 12 edges. And I'll let you guys go ahead and figure those out. Also, no, this is not part of the vertice. That altitude is there just to give us the height of the trapezoid. Um, all right, so let's keep going. So I know a lot of students, they pretty much have this down. Um, hmm, we're still struggling a little bit on things here, but I don't want to make a video too long, so I'm going to focus. First, I'm going to start this just in case you guys are stuck here, right? My base for this shape is going to be this triangle. And because this is a 3, 4, right, and this is going to be a right triangle, there's a 3, 4 blank triangle. I know that I already know this triple. All of us should know this triple. This is a 3, 4, 5 triangle, but if you don't know the triple, you can always use Pythagorean theorem. And let's say x squared. right? So you can go ahead and solve for x to get 5. From there, you can find your lateral area. Your lateral area is going to be 3 plus 4 plus 5. And then your area is going to be 3 times 4 divided by 2. So you can find both of those. Um, but the one I really wanted to go over was number 11. 11 is giving a ton of students difficulty, and it's a hard problem, right? It's a hexagon. So let's take a look here. So for this hexagon, the reason that, or this hexagonal pyramid, the reason that it gives so many students so many difficulties is just because we know that hexagons are made, we forget that hexagons are made from um, 6 equilateral triangles. Write that again. Will that work? Oh, I did it. Right, so I've got a hexagon here. It's made out of 6 equilateral triangles. I'm not going to draw them all in, but I just want to essentially, what I'm trying to do is find the base of this pyramid. And, and kind of looks like that, right? Now, so it's the same exact base. I know it's not perfect, but close enough. So I'm going to change it just like this, just so we can see it a little better. So here we know that this is a altitude. Now we need to know this because otherwise we're going to struggle heavily during the quick test if there is a hexagonal pyramid, right? So here, right, when we try to make this triangle, a lot of us are going to want to make this triangle using this edge, which is going to be a side of 4, and I'll explain why in a second, right? But that's not the triangle that we need to know because this is not its slant height. That is an edge height, right? So it's where the edge is. That is not its slant height. The slant height that I want to use is actually this one right here, this 9. But we have the slant height to be able to find the surface area. The problem is that we don't use the slant height to find the surface area. We use, in this case, right, it was 9. We use the height, the true height. And we need to figure out what that is. And the only way to do so um, is by understanding, by being able to find this side right here, or in this case, this would be the exact same side, right? It's just now you're seeing it from top bottom instead of from the side. So here, right, let's establish what we know. We know that hexagons are made up of equilateral triangles. So since side is 4 feet, this side, when bisected by the altitude, would give us 2 feet here, 2 feet here. But I'm not going to write 2 twice. I'm just going to mark them congruent. But remember, because these are equilateral triangles, this is going to be congruent to this. It's going to be congruent to this. Going to be congruent to this. Right? These are all equilateral triangles. So that means this is as a length of 4. Now, why do again I keep saying equilateral triangles? Well, when we bisect an equilateral triangle, remember that goes from having a 60, 60, 60 angle sum, right? Where all 3 angles are the same, so they're all 60, to being a 60, 30, 90 triangle. And now, again, some of you already see the pattern. This is a 30, 60, 90 triangle. We know A and we know 2A already. We need to find A root 3. A is 2, right? I already have 2A is 4. I didn't have to do any math, but we could have just multiplied 2 by 2. And so, in order to find my purple length there, my altitude in this case, or my side of the triangle here, I would have needed to use A root 3. So since A is 2, my answer for the 60-degree angle, so the altitude here, is going to be, or the side across the 60-degree angle, it would have been 2 root 3. So 2 root 3 is what my answer is here. So I'm going to go ahead and just label that inside because now let's go ahead. I'm going to make this all way smaller. We don't need it anymore. And I'm just going to put it up in the corner. Oh, I accidentally deleted the root 3. Okay, put this up in the corner here just so that it's away from our work. You can do it. Just make it small. Place it right there. Okay. Right now we have a triangle. We have a right triangle. Um, and this right triangle, right? This side is congruent to this side. I'm just drawing it so we can see it. This is 2 root 3. Its lateral height L is 9. In this case, though, it's my hypotenuse. And now we're able to find my height using um, the Pythagorean theorem. So here, what I would do is I would just say 2 root 3 squared plus uh, height squared, right? That's height that we're trying to find, equals 9 squared. So remember that 2 root 3 is just 2 squared is just 2 root 3 times 2 root 3. So this would give me 4, and then root 3 times root 3 is 3. So this is 12 plus h squared is going to equal 81. And now we subtract away 12 on both sides, and I get h squared is equal to 69. And then we can square root both sides to get a final answer. H is equal to the square root of 69. Now, 69 is not a prime. It can be divided by, actually, can it be divided? Yes, it can be divided into 3 and 23. 3 is a prime and 23 is also a prime. So because these are prime numbers, they just go right back in. There is no way to simplify square root of 69. And so therefore my height is just going to be square root of 69. Great. Okay. So I'm going to go ahead and make this really, really, really small again. Move it over. So let's see if we can start labeling some of these. And I'm not going to finish the problem for you guys. Uh, Actually, I might. Yeah, let's do it. Um, so let's just go over it. So it looks like, let's go ahead and name the figure. The name figure is a hexagonal pyramid. We need to find the lateral area. Remember, the lateral area for a pyramid is going to be perimeter times lateral height divided by 2. So I don't have my perimeter yet, but that's going to be easy to find. That's just 4 times the number of sides we have. Since this is a hexagon, that'd be 6. So 4 times 6. My perimeter is 24. So I'm going to do 24 times 9 divided by 2, which is 12 times 9, which I know that to be 108. And because we're talking about lateral area, that's 108 feet squared. All right, keep going. Find the total surface area. Well, the surface area, remember, is the lateral area plus the base, and B being the area of the base. So let's go ahead and find that. In order to find the area of a hexagon, we take 6 times the area of a equilateral triangle. Area of an equilateral triangle is s squared root 3 over 4. So we're going to do 6 times s squared times root 3 over 4. Since the side length is 4, we just replace s with 4. And now we do 6 times 16 times root 3 over 4. 6 times 16 is, I believe, 96. Yep, divided by 4 gives us 24. So the area of my base is 24 root 3. So let's go ahead and finish this off. So my lateral area is 108. My base area is 24 root 3. And since I cannot combine those, my total surface area is going to be, excuse me, 108 plus 24 root 3. We're almost done here. Almost done. So now let's go ahead and find the volume. Now remember, to find the volume of this pyramid, what we do is we take the uh, area of the base, we multiply that by the height, and then we divide it by 3, right? So let's go ahead and do that. I have my B, I have my H, so I'm able to solve for this. My base area is 24 root 3. And then we divide that, or we multiply that by the height being square root of 69. And divide that by 3. So when we do this, we actually should end up getting 8 square root of 3 times 69, 207. But 207 can be broken down. Let's see, what can I break 207 down by? Let's try 3. Oh, well, obviously it can be divided into 3 and 69. And then remember, 69 can be divided into 3 and 23. And then 3 is a prime. But because we have a pair of 3s here, that means we can pull out a 3. And now we have 8. And I'm running out of space, but that's okay. 8 times 3, right? Because what this would end up happening is you end up putting these back in, right? 3 times 3 is square root of 9. This goes back into my square root, so square root of 23. And then the square root of 9 is 3. Or if you guys just remember your trick, for every pair you pull out 1. So 8 times 3 times square root of 23. 8 times 3 is 24. And so my final answer here for the total volume of this hexagonal prism will be 24 square root of 23. And because it is volume, we use feet cube. We use cubic feet. And that is my final answer. Great. All right. So, oh, one more I'm going to help you with. This one here. Here we're trying to find the air around the balls inside of this cylinder. So what we need to do, and I'm not going to set this up, I'm just going to tell you how to do it, is what we need to do is we need to find the volume of the cylinder, then subtract away. It looks like we have 1, 2, 3 tennis balls. So we will have to subtract away um, the volume of 3 tennis balls, in this case being spheres. So now you should be able to solve for that one, and you should be all set. Great. If you guys have any questions, again, do not hesitate to um, email me, and I will try to make as many videos as I can over the weekend. Have a great rest of your weekend. Rest up and be prepared for the test on Monday. I'll see you guys then.